Hello, Math 2. This is Mrs. Bricky, and this is Unit 1, Lesson 3. We're going to be talking about binomials and distribution today. So first, just a couple of vocabulary words. So for polynomials, there's something called standard form. Standard form for polynomials is when the polynomial's terms are in descending order by degree. So standard form means that we want to have our most powerful term come first. It's kind of just an agreed upon way that we prefer to have our polynomials written, and kind of just gives us a little bit of uniformity. So if on this first polynomial, you might notice that the most powerful term is this y squared term. So this is going to start with y squared, and then this negative 4y is going to come next because our first term has two y's in it and our next term has one y. And then any constant term, which has a degree of 0, which has 0 variables, those always come last. So standard form for this first polynomial is y squared minus 4y plus 3. Something to be aware of, you might have noticed on the first example, is that the sign, if there's a sign like a negative, it goes with that polynomial that it is in front of. So I had a negative 4y here, and this 4y over here is also negative. So in this next polynomial, my most powerful term is this x to the third, but that's a negative x to the third. So my polynomial is going to start with negative x to the third. And then the term that it comes next would be the 15x. And then the constant 7 is going to come last. Not all polynomials have a constant. This next one does not have a constant, and that's okay. So I look for my most powerful term, and this one is degree 4 term. This term has degree 1. This term has degree 6. So it's the most powerful term. So for my polynomial, that's going to come first. And then I'll look for the next most powerful one, which is this 5m to the fourth. And then the 2m will come last. This last example, students often get confused on. I see a lot of times people want to write the standard form as y minus 1, but remember that negative goes with what it is in front of. So this polynomial would start with a negative y, and this 1 is a positive 1, so it's a negative y plus 1 for standard form. Okay, so another vocabulary word for today is leading coefficient. The coefficient of the term with the highest degree is called the leading coefficient. When the polynomial is in standard form, it is the coefficient of the first term, which is why it's called the leading coefficient. It leads the polynomial, but only if the polynomial is in standard form. So for this first polynomial right here, 5x to the fourth minus 6x to the third plus 4x minus 12, you can see that this one is in standard form, and so this is my leading term. It's the most powerful term, and the coefficient of that term is 5. So 5 is the leading coefficient. For our next polynomial, 28 minus 7x squared, that's not in standard form, but the coefficient of the most powerful term is negative 7. So negative 7 is the leading coefficient. If that was written in standard form, it would look like negative 7x squared plus 28. So when it's written in standard form, you can see that negative 7 does lead the polynomial. Pro tip, don't be caught off guard by understood coefficients or unwritten coefficients. This polynomial has a leading term of x squared. That is the most powerful term. Its coefficient is 1. It's not written there, but we understand it to have a coefficient of 1. This next polynomial is not in standard form. If we wrote it in standard form, it would be negative x squared plus 7, and that has a leading coefficient of -1. So if the coefficient is a 1 or a -1, we won't necessarily see the 1 there. So just be aware of that. Okay, class, we may have done this activity. All right, so last class we did some operations with monomials. We added together monomials and combined like terms, and we multiplied with binomials. But today we're going to focus on with monomials last time. Today we'll focus on binomials. We are not going to be doing the operation of division, but if you take Math 3, you will talk next year about how to divide polynomials. And today, from now on, today we'll report all of our answers in standard form. Just as with monomials, when we add binomials, we combine like terms. Like terms, again, that means that they have the same variable with the same power. So if I want to find the sum of the binomial 7x plus 5 and the binomial 2x plus 1, if I want to add those together and find their sum, I think about what the like terms are. Well, these two terms both have the variable x, so we can combine them into a 9x. And then these two terms are both constant terms, and so we can combine them to get a total of 6. So the sum of 7x plus 5 and 2x plus 1 is 9x plus 6. Often addition problems will be written with grouping symbols, which can sometimes make it look a lot more difficult, but it is exactly the same idea, and we are still just looking for terms that can combine. So when you look through all of the terms in these two binomials, you might notice that these two terms can combine. But none of the other ones have a term that they can combine with. If they can't combine with anything, they just stay themselves. So I'm going to start my answer with that most powerful term, x squared. And now I have this 7x, which is going to combine with a negative 3x to give me a total of 4x. And then I also have this constant 5, and there isn't any other constants to combine with that 5. So that 5 will just stay as part of my answer. So when I add these two binomials together, I get x squared plus 4x plus 5. Well, you might have noticed that, for example, 1, when I added together two binomials, I got a binomial answer. But in example 2, when I added together two binomials, I got a trinomial answer. Just like when I add two monomials together, I might end up with a monomial or I might end up with a binomial. It really just depends on how many like terms there are. So you just have to be mindful that, the number of terms in your answer can vary depending on which terms are able to combine. So in this example 3, I do have a 7x that can combine with this negative 7x, but when I have a 7x and a negative 7x, they combine to give me 0x. And so I don't need to write that term in my answer because it's just 0. I also have a constant 5 that can combine with this constant of 4, and so I get 9 as my answer. So this is a monomial. I'm going to go for the video to the next slide here. Subtracting works much the same as addition. Just remember that the subtraction applies to each term of the binomial after the subtraction symbol. So you need to decide a way that you like to rewrite it that makes the most sense to your brain. Sometimes people I have kind of two strategies shown up here. Sometimes people use this strategy of like writing the little minuses with each term. Like they kind of move that negative into both terms and then they change this to a plus. Or if you prefer, you can just kind of do a rewrite step where you move the negative in and you just rewrite it on a separate line. I'm going to do it as a separate line. If you like to use this shortcut sort of shorthand, you can. So this is 7x plus 5 minus 2x plus 1. So the 7x plus 5, I'm subtracting a 2x and subtracting a 1. So I moved that subtraction into each of those terms. So then when I combine them, the 7x and the negative 2x can combine because they're alike, and then the 5 and the negative 1 can combine because they're alike. So I end up with a difference of 5x plus 4. Okay, so in this example 5, I have a 7x plus 5, and I'm subtracting an x squared minus 3x. So that's minus x squared and then minus negative 3x. And hopefully you remember, if we subtract a negative, it's the same as adding. So this is a plus 3x. In this case, the most powerful term is that negative x squared, so I'm going to write it first. I have the 7x that can combine with the 3x for a total of 10x. And then there's not another constant to combine with that 5, so it just stays as a constant in my answer. Kind of cut off my power there. So our answer for example 5 is negative x squared plus 10x plus 5. So for example 4, I got a binomial answer. For example 5, I got a trinomial. And then let's see what happens on example 6. So I'm starting out with a 7x plus 5, and I want to subtract a 5 minus 7x. So that's a minus 5 and a minus negative 7x. So that's a plus 7x. So when I add them together, the 7x and this other 7x can combine to give me 14x. But 5 minus 5 is 0, so 14x is my answer, and in that case, I got a monomial answer. All right, so addition and subtraction, we're really just looking for like terms to combine. Okay, so here is a couple of problems that are written out with mystery numbers. We want to try to figure out the missing number that goes in each box. And to do this, you want to focus on like terms. So I'm going to use some highlighting. So in this first expression right over here, I've got this 5x, and then I also have a like term with the 3x, but there's a subtraction symbol there. And then over here I have a mystery number in front of my x. Well, since I've highlighted those like terms, you can see that 5x minus 3x gives me 2x. So the mystery number in that box is a 2. Let's get rid of this. And now I'm going to focus on the constants. So this is a constant plus this mystery number. I've got a minus 1, and it needs to add up to 7. So something minus 1 is equal to 7. That mystery number over here must be 8. 8 minus 1 gives me 7. And if you want to highlight your paper in different colors to help you focus on like terms, that is a great strategy. Okay, so on this one, I can see some terms that have b squared, some terms that just have a b, and I can see some constants. So I'm going to highlight all of the b squareds. So for all of the b squareds, it looks like I have a mystery number of b squared plus 4b squared is equal to 6. So that must be 2, because 2 plus 4 gives me 6. And then I'm going to look for all the ones that are just b. And I just have these two, 8b on one side of the equation and a mystery number of b on the other. Well, those have to be the same. They have to both be 8. And then finally, for constants, I have 2's, and that's already there. I don't have to worry about it. Okay. All right, so if you want to try the addition and subtraction practice on your assignment, you can. And then we also today are going to do a little bit of multiplying. When two polynomials are adjacent to each other and no operation is seen, the operation is understood to be multiplication. So in this case, I've got this 5 right next to the binomial 3x minus 4, so that is understood to be multiplication. If you want, if the goal is to do some other operation like addition, you have to be able to see that operator there. We're going to work on multiplying right now, and sometimes people start to think that parentheses mean multiply, but it's really not parentheses that mean multiply. It's really adjacency. So when the 5 is next to the group of 3x minus 4, that's telling me to multiply. If it says 5 plus 3x minus 4, well, then I know I need to add. And these have way different answers. This one would have the answer 3x plus 1, and this one would have the answer 15x minus 20. Okay, so we are going to now talk about what I just did right here, which is distribution. When you are multiplying binomials or a monomial with a binomial, you have to use the distributive property of multiplication, which I did just barely here with the 5. I did 5 times 3x to get 15x and 5 times negative 4 to get negative 20. But we can also use the distributive property of multiplication with variables or with other types of monomials, mixtures of variables and numbers. So we've got 3 examples here where we have a monomial and we're multiplying by a binomial. So we've got an x multiplied by a 3x. Well, that gives me 3x squared. And then I also need to multiply this negative 4 by x. So the x multiplies both terms in that binomial. And so I have the answer 3x squared minus 4x. Do try to just kind of mentally check to make sure your answers are in standard form. So in example 9, I have a negative 2w that I want to multiply by the binomial 1 plus 8w. So the negative 2w has to multiply both terms of the binomial. Negative 2w times 1 is negative 2w. Negative 2w times 8w is negative 16w squared. Now, I've multiplied correctly, but I should report my answer in standard form. So I just need to rearrange those terms to make the most powerful term the first term. Okay, and now finally I have a 9x squared that's being multiplied by the binomial x plus 3. So the 9x squared has to multiply both terms in the binomial. So I get 9x to the power of 3. Remember that this is an x with the power of 1, so this first term in my answer is going to be a power of 3. And then the 9x squared multiplied by 3 gives me 27x squared. And that one is in standard form. Okay, you can try a couple if you want. For the video, I'm going to skip ahead. Now, sometimes we want to multiply, very common in math, we want to multiply a binomial by another binomial. And in this case, we do have to be careful how we distribute. This first binomial starts with the term 3x. Well, that 3x needs to multiply both of the terms in that second binomial. The 3x multiplies by the 2x to give me 6x squared, and the 3x multiplies by the 5 to give me a negative 15x. So that would complete multiplying by the first term of the binomial, but I also have to multiply by the second term, the 4, and that 4 also will distribute and multiply by both the 2x and the negative 5. So 4 times 2x gives me 8x, and 4 times negative 5 gives me negative 20. When you are multiplying binomials together, you end up with 4 terms. And when you look at that list of 4 terms, you will often see terms that can combine. Not always. It's possible that you won't, but oftentimes you see two terms that can combine. And you do want to go ahead and combine them if when you notice that there are some like terms there. So when we combine that negative 15x with the 8x, we get a negative 7x. The 6x squared stays in our answer and the negative 20 stays in our answer. There's not a like term for those to combine with. Just those two middle terms will combine. So then our final answer would be 6x squared minus 7x minus 20. Let's try a couple more of those. So we're going to multiply a plus 3 by a plus 2. So first I'm going to distribute the a, so that gives me an a squared. And then I also need to times the 2 by the a, so I get 2a. So I've distributed that first term, that a, and now I need to distribute the 3. So then I have an additional 3a, because that's 3 times a, which is 3a. And then 3 times 2 is 6. So I ended up with these 4 terms. I look and check to see if any of them can combine, and those two can combine because they both are a with the power 1. So my answer is going to start with a squared. The 2a and the 3a combine to give me 5a, and then I have the constant 6. So a squared plus 5a plus 6. Let's try that again. So for example, 12, I want to multiply 4r plus 2 by r minus 1. So I need to distribute both the 4r and the 2. So I'm going to distribute the 4r. 4r multiplied by r gives me 4r squared. 4r multiplied by negative 1 gives me negative 4r. I finished distributing the 4r, and now I'm going to distribute the 2. 2 times r is 2r. 2 times negative 1 is negative 2. I have my 4 terms written out, and I look for ones that can combine. It's often the middle two, but not always. And I can combine that negative 4r with the 2r. So my final answer starts with that 4r squared. I've got the negative 4r combining with the positive 2r to give me a negative 2r. And then I've got the constant negative 2. Okay, one more binomial to multiply. So we've got an x minus 5. We're multiplying by 9 minus 7x. So first the x is going to distribute to the 9. So that gives me 9x. And then x times by negative 7x is negative 7x squared. Now I need to distribute the negative 5. Negative 5 times 9 is negative 45. Negative 5 times negative 7x is positive 35x. Now, in this case, the middle terms don't combine. The terms that can combine are these two on the outsides. That's okay. You just want to look for the ones that have the same variable with the same power. So my answer, when I write it, it's going to start with that most powerful term, which is the negative 7x squared. And then I'm combining the 9x with the 35x, which is 44x. And you can, of course, use your calculator to add those together. And then I've got that constant negative 45 term coming last. You might have noticed that when we are multiplying two binomials together, our answers so far have been trinomials. It is possible to get an answer that has only 2 terms. It's also possible to get an answer that has 4 terms. I do want to show you one where you get a binomial as your answer. If you were multiplying x plus 5 by x minus 5, you would get x squared minus 5x, and then we have a plus 5x and a minus 25. So you can see that those two middle terms in this case, they add up to 0x. They cancel each other out. So we end up with the answer x squared minus 25. So it is possible to get a binomial for your answer. And it is also possible to get 4 terms where none of them combine. Okay, let's connect the idea of polynomial operations to some shapes. We're going to just look at 3 more examples, and then this lesson will be done. So we've got a little parallelogram here, and it says, write a polynomial in standard form that represents the perimeter of the figure. So remember, perimeter means add up all the sides. So when we're adding together polynomials, binomials, and monomials, remember we're looking for like terms. So we've got 2x, 3x, 2x, and 3x. Those can all combine, and they would combine together to give us 10x. And then I've got a 1 here and a 1 here, so that would be a plus 2. So my perimeter of this shape is 10x plus 2. Here we have, our instructions say create a polynomial in terms of x that represents the area of the rectangle. Remember that area for a rectangle is length multiplied by width. So I want to multiply together these two polynomials. So the length multiplied by the width means I'm multiplying that 2x by the 5x plus 3. So if I distribute that, I get 10x squared plus 6x. So that is an expression for the area of the rectangle, 10x squared plus 6x. And finally, our last example says if the perimeter of this triangle is known to be 18x minus 1, write an expression to represent the length of the hypotenuse. So this is the hypotenuse. I want to find an expression for its length. Well, I know that the total perimeter is 18x minus 1. Whoa, I did not write 18x minus 1. Let's try that again. 18x minus 1. This is the whole perimeter. So if I subtract the sides that I can see, it should leave me with that hypotenuse. So I'm going to subtract the 4x and subtract the 6x plus 8. And you may have thought of a different way to do this. If you did, that's fine. There's definitely more than one way of thinking about it. So I have the whole perimeter, subtract the two sides that are labeled, and when I complete that subtraction, it should give me the hypotenuse's length as an expression. So I've got an 18x minus 1, I'm subtracting a 4x, and then I'm subtracting a 6x and subtracting an 8, because remember that this subtraction symbol applies to both of the terms there. So if I combine like terms, this guy can combine with these two to give me 8x. 18 minus 4 minus 6 leaves 8. And then I have a negative 1 and a negative 8, so that's negative 9. And that's the that's the length of that hypotenuse, 8x minus 9. All right, that's it for this lesson. You should have an assignment. If you're not sure what it is, talk to your teacher and let your teacher know if you have any questions. Thank you.